Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Patna. The title of this lecture is Design of Key Value Stores for IoT Edge Storage. So, content of this lecture is as follows. We will cover the design of data stores often used in Azure Edge IoT applications. We will then design and give an insight of some key value NoSQL storage, which is used in today's edge storage systems. We will also discuss one of the most important cloud storage system, that is called Apache Cassandra, and various different consistency solutions which are being provided by Cassandra. Now, let us see about an IoT edge data flow. So, initially the data is collected from Azure IoT sensors and passed through Azure IoT gateway, and then we need to pull the data from Azure IoT edge using stream analytics, and then stream that data to and from IoT edge to the data store or the databases. Let us see for an IoT edge. Let us say it is having the IoT sensors or an IoT device monitoring a particular physical phenomena. When this particular IoT sends the data to an hub, that is edge IoT, Azure IoT edge, that is called edge gateway, and this particular gateway then forwards the data for stream analytics and often stored in the storage device. So, the data IoT data requires some kind of storage technologies to store this IoT data. Now, you know that IoT data is called a time series data. So, you require time series databases, and these databases often requires to be supported at the edge. So, we are going to discuss about this kind of technologies which is going to support at IoT edge data flow. So, let us see the edge part. The edge contains various type of protocol support. Some of them are listed over here, that is messaging and the services support called Kafka, MQTT, REST APIs, and the cloud native services such as IoT Core or IoT Hub will support all of them, and we do not have to see the intricacies of each and every protocol independently. So, cloud native service for IoT will support all of them, that is, and they will give the messaging and services. Now, this particular enablement will now integrate with all the IoT devices to communicate their data or to communicate it with edge. So, here you can see that this kind of edge requires this embedded edge will have the embeddedness of or support the technologies for the database, and this particular gateways also supports the connectivity at the edge or enablement for time series data analytics also to be performed at the edge, and these analytics are called hot data analytics because they have to support the stream analytics like we have seen in the previous figure, and also ensure the data locality. That means, you cannot afford to send this type of data which requires hot data analytics to be sent to the cloud. It has to be done at the edge. So, all kind of support, that is what cloud used to do, has to mimic at the edge level, and most important thing is that how are you going to store the time series data. So, therefore, on the cloud side also to support this hot data analytics, high availability and horizontal scaling and data locality, cold data analytics and so on are some of the enablement at this particular public cloud. You know that public cloud provides various kind of connectors, and these connectors will support these kind of databases and other functionalities in the cloud are enormous. Now, let us see about how are we going to discuss the data storage or databases to be provided at the edge like cloud. So, let us see about what are the most important popular databases which the cloud uses for different IoT applications and now can be supported at the edge as well. So, to select the right storage for the time series and IoT domain, it depends upon the data access methods that you require with the databases. So, first one is called the hot database, the second one is called the cold database. Hot database means the data that is frequently being queried or updated, often a good choice for storing the data as they read and write capabilities with a little latency at a lowest cost. Whereas, cold database means stored in their original state with little or no changes made thereafter. And these are two different type of. Now, let us see about NoSQL with built in different applications. So, NoSQL, some of the databases are Bigtable, HBase, Cassandra and so on. Strong side is that they are extremely well scaled for writes, performing basic level of analytics. Now, NoSQL purpose built time series database, and it is providing all different type of applications. So, as you know that let us take an example of an edge databases. Here the continuation of series of lectures about IoT data analytics. Let us use one such IoT application, that is called fitness tracker, and this particular fitness tracker consists of the set of observations, and the observation contains the sensors or the edge which measures the heart rate, elevation, steps and so on. So, these metric will be generated by the sensor at the time, these time are mentioned over here, and the text or context description in which the given sensor is generating the data. That is the device model, geography, location, user, activity type and so on. So, let us see about the functional requirement, that is the simple data retrieval. Here the random data access and the small range scans are some of the basic necessity which is required, and then time window normalization is also some of the functionalities which requires here in this particular manner. So, scale. So, let us see about non-functional requirements, that is crucial to consider the main drivers of these applications, such as scalable storage, scalable writes, scalable reads and high maturity. These are some of the non-functional requirements. Now, let us see about what do you mean by the key value abstraction. So, key value abstraction, which is also called NoSQL databases, provides, and you know that the time series data or the IoT data can be classified as key value store. So, let us take in any business what do you mean by key and what is the value. So, let us say that if the business is flipkart.com, then in that case the item number will become the key and the information about that item is the value. Similarly, let us say another application that is called Ease My Trip. Here the flight number will become the key and the information about the flight, that is availability, that will become the value. In Twitter.com, tweet ID will become the key and the information about the tweet will become the value. MyBank.com, here the account number will become the key and the information about it will become the value. So, is it a kind of database key value store? Yes, it is a kind of database, and but it is quite different than RDBMS or a MySQL that we have now seen, which normally supports the language that is called a query language, and also in that query language you can see that the operations such as joins are often there. So, take this particular example of a relational database. Relational database is now having two tables. One table is called the user table, the other table is called the block table. These two tables can be combined with the help of the foreign keys. Now, here the primary key of user table and the primary key of the next table, that is the block table, will become the foreign key here in the user table, and using that both the table can join the operation, and then user can write down different queries using structured query language in relational database management system. Now, what about today's workload? Let us say that IoT workload is not fit into the relational database management, therefore, there is a requirement of a key value store. We often call it as a NoSQL. NoSQL. So, here the data is large and unstructured, that is difficult to come with the schema where the data can fit, and it is having the lot of reads and writes coming from millions of the client, and here it is sometimes write heavy, that is lots of write compared to the read. And next important thing is that foreign keys are rarely needed and joins are infrequent here in this particular case of today's workload. Therefore, there is a need of support of a new type of database called NoSQL, where speed is important, avoid a single point of failure and low cost of operation and total cost of ownership, fewer system administration, incremental scalability, scale out and not scale up. So, all these are required in edge and cloud kind of system, where scale out, that is incrementally grow your net cluster capacity by adding more COTS machine, that is component of the self machine. Now, let us see about the key value store data model, which is also called NoSQL data model. Full form of NoSQL is not only SQL, and it requires two necessary API operation, get by key and put by key value, and the Cassandra has its own language which is called Cassandra query language in key value store. Now, the tables in this key value store or a NoSQL, they are called column families in Cassandra, table in HBase and collection in MongoDB. So, it is these tables are like RDBMS, but quite different. They may be unstructured and does not require to support joins or foreign keys and have the index table like RDBMS. Take this example, how is it different from RDBMS or this key value store. Here it is unstructured, that is here that it is having key and rest of the all attribute will become the value, and here there is no schema imposed, that means some of the row entries may be or some of the column entries may be missing, yet that is not a problem, and there is no foreign keys present here. Why? Because joins are not supported. So, these are some of the functionalities of key value store, which is very much needed in today's workload handling, let us say that IoT type of applications. Now, column oriented storage, this is called, and why this is useful? Because it uses the range, supports the range queries with the column, which are fast, since you do not need to fetch the entire database, and you can use or you can retrieve the data with the help of key in this case. Let us see the design of one such key value abstraction, that is called Apache Cassandra. Now, the Cassandra is a distributed key value store and it is intended to run in the data center, that is across the data centers. Originally it was designed the Facebook and today open sourced, and later it is an important Apache project, and some of the important companies that use Cassandra in their cluster, they are IBM, Adobe, HP, Ericsson, Twitter, PBS Kids, and Netflix also uses Cassandra to keep track of the positions in the video. Therefore, you can see that most of the internet applications are using this particular Cassandra, that is nothing but a distributed key value store, and it runs inside the data center, whether it is an edge data center or a cloud data center, it runs over there. Let us see about the inside design of Cassandra. So, first important operation which Cassandra supports is called key to the server mapping. So, given a key, because key and value together has to be stored in that particular Cassandra. So, important thing is, given a key, in which server it is going to be stored, that is called key to server mapping. Now, to do this, Cassandra uses the ring based distributed hash table, but without using the finger table or the routing which is used in distributed hash table. So, key to the server mapping is often called the partitioner. So, this particular program is called the partitioner. Now, this particular key to the server mapping decide which server the key value pair resides. Now, the next is, once the server is identified using key to the server mapping, then there are two important strategies which need to be decided, that is how the replication is to be done. There are two ways to do the replication in Cassandra: simple strategy and network topology strategy. Simple strategy uses the partitioner, of which there are two types of partitioner. One is called random partitioner, which is called like hash partitioning. The other is called byte order partitioner, which assigns the ranges of the keys to the servers, easier for the range queries. Network topology strategy for multi data center deployment, 2 replicas per data center or 3 replicas per data center, that is called network topology strategy. So, per data center, the first replica is placed according to the partitioner and then go round the ring until you hit a different rack. So, these are all called data placement strategy. Then snitches are the second important design concept here in Cassandra, where the IP to the racks or data center is mapped. So, it is configured in Cassandra.yaml configuration file. Some of the options are called simple snitch, rack inferring snitch, then property file snitch, EC2 snitch, and other snitch options. So, when you say a simple snitch, that is unaware of the topology, that is rack unaware topology is being used. Rack inferring, that is assuming the topology of the network by the octet of the server's IP address. So, take this example of an IP address 101.102.103.104. Here you can see that the second octet will identify the data center where it is going to be mapped. The third octet is referring to the rack, and finally, the fourth octet is the node within that particular rack, and this way it is called rack inferring snitch. So, IP to the rack and the data center. So, given an IP, if it is a rack inferring, you can infer about which data center, which rack and which node will be now identified. Similarly, property file snitch uses the configuration file. EC2 snitch uses EC2 instance, which you have seen in Amazon AWS. So, it consists of EC2 regions, that is nothing but the data center and the availability zone within that particular data center, that is the rack. So, if it is an EC2 snitch, then also you will know that in a particular cloud, that is AWS, where in which region your data is going to be stored using that snitch, and in that data center which particular rack will be used to store your data. Data location is going to be understood in this way. Now, let us see about the operation, the write operation. So, need to be lock free and fast, that is no reads or disk seeks is required, and the client sends the write to one of the coordinator node in the Cassandra cluster. The coordinator may be a per key basis or per client or per key per unit query basis. Now, per key coordinator ensures the write for the key are serialized. Now, coordinator uses partitioner to send the query to all the replica nodes and responsible for the key. When X replica responds, the coordinator returns an acknowledgement to the client. So, what is the value of X that we are going to discuss later? Now, writes always writable, that is using hinted handoff mechanism. If any replica is down, the coordinator writes to all the replicas and keep the write locally until down replica comes up. When all the replicas are down, then coordinator, that is front end, buffers the writes up to the few hours. Now, one ring per data center, that is per data center coordinator elected to coordinate with the other data center. Now, election is via zookeeper, which runs a Paxos, that is consensus variant. So, writes at the replica nodes. On receiving a write, the logs it in disk commit log, that is failure recovery, make the changes to the appropriate mem table, and mem table is in memory representation of a multiple key value pairs, typically append only data structure, and that is why it is very fast. The cache that can be searched by the key and write back as opposed to the write through. Later, when mem table is full or old or flush to the disk, so the data file, that is an SS table sorted string table, that is a list of key value pairs sorted by the key. SS tables are immutable, that is created, once created they do not change. Index file, that is an SS table of key position in the data stable pairs, and also uses the Bloom filter for an efficient search. So, you can see that the write will become quite fast, because it is using the in memory representation of multiple key value pairs, and it only supports the append only data structure, and often for the search it uses the Bloom filter. Why? Because the mem table is old or flush to the disk, that is the data file is stored in the form of SS table, which is nothing but a list of key value pairs sorted by the key, and SS tables are immutable, once created they do not change. And also there is an index file, that is an SS table of a key position in the table pairs are there, and for have the efficient search it requires a Bloom filter. So, we skip the Bloom filter design, it is a compact way of representing the items, and it is used for an efficient search. Now, let us see about the compactation. Data updates accumulate over the time, and SS table and the logs need to be compacted. So, those features are there. Delete, do not delete the item right away, rather it will add a tombstone to the log, and eventually when the compactation encounters tombstone will delete the items. Now, let us see the writes, reads. Reads are quite similar to the writes, except the coordinator can contact X replicas, that is in the same rack. So, coordinator send the read to the replicas that have responded quickest in the past, and when X replica responds, then coordinator returns the latest timestamp value from among those X. So, what is that X? We will check it later. So, coordinator also fetches the values from other replica, checks the consistency in the background, initiate the read repair, and if any two values are different, then this mechanism seeks to eventually bring all the replicas up to date. Now, at a replica, a row may be split across multiple SS tables. that is the read need to touch multiple SS tables and the reads are slower than the writes, but still it is fast. Now, let us see about the membership. So, any server in the cluster could be the coordinator. So, every server need to maintain a list of all other servers that are currently in the server, and this particular list need to be updated automatically as the server joins, leaves and fails. So, cluster membership is done with the help of the protocol which is called a gossip style protocol, and Cassandra uses the gossip based cluster membership protocol. Now, there is a suspicion mechanisms in Cassandra. So, suspicion mechanism to be adaptively set the timeout based on underlying network and the failure behavior. So, these particular mechanisms allows the failure detection in the Cassandra. Now, let us see about the difference between the Cassandra and regular means relational database management system. Now, out of that MySQL is one of the most popular RDBMS on the data which is more than 50 GB. Let us compare both of them performance. So, MySQL writes takes the writes 300 milliseconds on an average and reads takes 350 milliseconds on an average in MySQL. Cassandra takes only let us say 0.12 milliseconds on an average and reads take 15 milliseconds on an average. So, it is an order of magnitude faster. So, what is the catch, how do we lose, that we are going to see, and what are the advantage, what are the new applications where Cassandra can be used, but not MySQL. So, you can see that all the applications which are running on the internet often uses Cassandra, not MySQL. Why? Because of these particular writes are so fast, reads are also quite fast compared to the MySQL. So, orders of magnitude are faster. So, the businesses which are running requires these fast speed, otherwise users may churn, customers may churn on the internet. Therefore, Cassandra is a new technology which is being used in these things. Similarly, let us say the real time application requires these particular times, let us say write and read to be much faster. If it is the edge computing, then latency is going to be an important paradigm, and for an IoT application or any other application such technologies are being used. So, therefore, we are discussing this Cassandra for latency sensitive application. Now, let us see about the difference which we see that why this MySQL or RDBMS is slower compared to the Cassandra. So, there is a theorem which is called a CAP theorem. So, CAP theorem is proposed by Eric Brewer and subsequently proved by Gilbert and Lynch. So, in a distributed system you can satisfy at most 2 out of 3 guarantees: consistency, availability and partition tolerance. So, out of 3 only 2 can be guaranteed, and this is called a CAP theorem. CAP means C is for consistency, A for availability, P for partition tolerance, and this is called a CAP. So, consistency means that all the nodes see the same data at any time or returns the latest return value by any client. Availability, that is the system allows the operation at all the time and the operation returns quickly. Partition tolerance says that the system continues to work in spite of the network partitions. Let us see about the availability. So, reads and writes complete reliably and quickly. So, measurement have shown that 500 millisecond increase in the latency for operations in let us say Amazon.com or a Google.com, that is in the cloud, can cause 20% drop. So, latencies are very important. So, latency sensitivity has to be ensured in the availability. So, imagine that each added milliseconds of latency will implies yearly $6 million loss. So, user cognitive drift, that is more than a second elapses between the clicking and material appearing, the user's mind is already somewhere else and this is going to lose the business. So, therefore, service level agreements are written by the provider predominantly deal with the latencies faced by the clients. So, availability is going to be important considerations in some of the applications. The other important aspect is called consistency, that all the nodes see the same data at any time or returns the latest return value by any client. So, when you access your bank account or investment account via multiple clients such as laptop, workstation, phone, tablet, you want to see the updates done from one client visible to the other clients. When thousands of customers are looking to book a flight, all the updates from the client that is booked should be accessible by the other clients. So, consistency in some of the cases are going to be an important factor. Now, third important factor is called partitions. Now, partition can happen across data centers when the internet gets disconnected. So, that is called internet router outages, undersea cable cut, DNS not working, all of them going to make this particular partition across the data center because of these outages, whether internet router outage, undersea cable connect, DNS or not. Partition can occur within the data center, that is a rack switch outage. Still, it is desired to have the system to continue functioning under the normal scenario, even tolerating the partitions or faults. So, what is the CAP theorem fallout? Since the partition tolerance is the essential in today's cloud computing and the edge computing system. So, CAP theorem implies that the system has to choose between consistency and availability. Now, let us see the Cassandra. Cassandra chooses a weak form of consistency, that is, it chooses availability over the consistency. So, out of 3, that is CAP, so Cassandra chooses availability and partition tolerance, where C is called eventual consistency. Now, traditional databases have the strong consistency over the availability under the partition. So, let us see about the CAP trade off. So, starting point for NoSQL revolution, here a distributed storage can achieve at most 2 out of 3. So, when partition tolerance is important, you have to choose, if partition tolerance is important, you have to choose between consistency and availability. So, here in this example, you have to pick 2 out of 3. So, let us say that if partition tolerance is already decided most of the cases. So, out of consistency and availability, let us see what are the options. So, if availability is preferred over the consistency, then these kind of key value stores called as Cassandra, React, Dynamo, Waddlebot. When consistency is chosen over availability, then you can see that you have HBase, Hypertable, Bigtable and Spanner. These are some of. Now, here you can see that RDBMS is not replicated, therefore, partition is not there, it is full, it is running on a single server machines. So, it is consistency and availability is ensured. So, eventual consistency which is there in Cassandra, let us understand about that. If all writes stop to a key, when all its values, that is a replica, will converge eventually. So, if the writes continue, then the system always tries to keep converging. That means, there is a moving wave of updated values lagging behind the latest values sent by the client, but always trying to catch up, may still return the stale values to the client, but works fine when there are few periods of low writes and the system converges eventually. Therefore, it is not the instant consistency, but it is an eventual consistency. So, if we see RDBMS versus key value store, so RDBMS follows the ACID properties for the transaction, that is atomicity, consistency, isolation and durability, whereas the Cassandra follows the base property, that is basically available soft state eventual consistency. basically available soft state eventual consistency. Why? Because Cassandra prefers availability over the consistency. Now, consistency in Cassandra comes in various levels, and therefore, client is allowed to choose a consistency level for each of the operation, that is read and write. Any means any server may not be the replica fastest who can give the values. So, the coordinator caches the write and replicas quickly to the client, and all means all the replicas ensure that a strong consistency, but the slowest, and one is at least one replica that is faster than all, but cannot tolerate failure. Quorum is that quorum across all replicas in all data centers. So, quorums for the consistency, in a nutshell, the quorum means that majority, that is more than 50%. So, any two quorums intersect, that is the client 1 does a write in the red and client 2 does the read in the blue, in a blue quorum. So, you can see that at least one server in a blue quorum returns the latest write, and the quorums are faster than all, but it still ensures the strong consistency. So, quorums are used here in this particular design and will ensure the fast way of doing consistency. So, quorums in details. So, there are several key value and NoSQL storage, such as React and Cassandra use quorums. So, as far as the read is concerned, client specifies the value of R, which is less than or equal to n, that is total number of replicas of that key, and R is nothing but the read consistency level. So, coordinator waits for R replicas to respond before sending the result to the client. In the background, the coordinator checks for the consistency of the remaining n minus R replica and initiates the read repair. So, that is how the consistency, eventual consistency is preserved. So, writes comes in two flavors. So, the client specifies write W, which is less than or equal to n, that is upper bounded by n. So, write consistency levels are set here in this case. So, client writes a new value to W replicas and returns two flavors, that is the coordinator blocks until the quorum is reached, asynchronous, just write and return. So, there are two necessary conditions, that is W plus R is greater than n and W is greater than n by 2. Now, you have to select the values, plug in the values of W and R. So, that means if W is 1 and R is 1, then very few writes and reads are there in the system. When W is equal to n and R is equal to, then it is good for read heavy workloads, and when W is equal to n by 2 plus 1, R is n by 2, then it is great for write heavy workloads. When W is 1 and R is equal to 1, that is great for write heavy workloads with mostly one client writing per key. So, there are different consistency levels, quorums, local quorums, and each quorums, all these are, there are different type of consistency, let us understand them. And so, consistency Cassandra offers is called eventual consistency. There are other types of weak consistency models. So, let us go through them. So, consistency solutions which are provided. So, Cassandra offers eventual consistency. So, if the writes to a key stops, then all replicas of a key will converge. So, originally this particular design was from Amazon's Dynamo and LinkedIn's watermark system. So, let us see about the consistency level. So, between this eventual and strong consistency. So, as we move the consistency away from eventual towards strong, this means that what we are doing is we are using the faster, we are moving away from faster reads and writes. So, that means the way moving towards eventual consistency means it is reads and writes are much faster. So, let us see about the newer consistency modes. So, striving towards strong consistency while still trying to maintain high availability and partition tolerance. So, newer consistency models are seen over here, like causal consistency, eventual between eventual and strong, it is a causal red blue, probabilistic, per sequential, CRDTs. They are all different type of consistency level which are striving towards strong consistency level, while still maintaining a high availability and partition tolerance. So, let us see some of them. So, per key sequential consistency level, where all the operations have the global order, CRDTs, that is cumulative replicated data types, CRDTs. So, data structure for which the commuted writes gave the same result, that is value is equal to int and only op is allowed is +1. Red blue consistency, here what we can see is that we can rewrite the client transaction to separate the operation into red operations versus blue operations, and the blue operations can be executed in any order under the data center. Red operations need to be executed in the same order at each data center. Now, another form of consistency is called causal consistency. Here the reads must respect the partial order based on the information flow, and this is being developed at Princeton. So, here you can see there are 3 clients A, B and C. So, in causal consistency, as we have seen in time ordering, there is a happened before relation. So, that is called causal. So, here causal concept is also brought into the consistency level, that called causal consistency. So, here you can see that this write operation for a key with a value k 1 is equal to 33 is now happened before this read operation of key k 31, which returns 33. Similarly, the write for key k 2 is 55, and now this particular read is dependent upon this write k 2, that returns 55, and then you can see that read for key k 1 is also dependent upon. So, this will also return. So, you can see that the causality is ensured here in this particular way, the messages are being flowing and communicating. So, causal consistency is quite close to the eventual consistency, hence the read and writes are quite faster. Now, which consistency model should you use? So, with the lowest consistency to the left, that is consistency model that is correct for your application and get you fast availability. Now, let us see about the strong consistency models. So, strong consistency models are, some of them are linearizability. Here each operation by the client is visible or available instantaneously to all other clients. So, instantaneously in real time. So, this is a quite strong consistency model. Sequential consistency is given by the Lamport, that is the result of any execution is the same as if the operations of all processors were executed in some sequential order and the operations of each individual processor appears in the sequence in the order specified by its programs. So, after that fact, finally reasonable ordering of the operations that obey consistency at all the clients across all the clients. Now, the next type of consistency which ensures the ACID properties, for example, is a newer key value, that is NoSQL stores which are happening, and they are called new SQL. So, new SQL is a new key value store design which ensure the ACID properties like RDBMS, and they are called transaction ACID properties which are being followed, and that type of databases key value store, they are called new SQL. Some of the example new SQL technologies which are being developed, they are called Hyperdesk by Cornell, Spanner by Google, and transaction chain by Microsoft Research. Conclusion. So, in the traditional databases, that is RDBMS with a strong consistency and offer the ACID properties, modern workloads in let us say that IoT applications do not need such a strong guarantees, but do need fast response, that is availability and latency sensitivity. So, unfortunately, the CAP theorem is there in the cloud and edge system to be effective, and this particular cap theorem influences the design of a key value or a NoSQL system to offer not the acid properties, but a base properties, that is basically available soft state eventual consistency. So, eventual consistency and a variety of other consistency models is striving towards a very strong consistency, but it is not a strong consistency, it is basically available soft state eventual consistency. Now, we have also discussed the design of Cassandra and different consistency model. Let me summarize that in the edge and cloud system, we require the cap theorem to be implemented. With the help of cap theorem, what we have seen is the key value store design such as Cassandra, which ensures the availability and partition tolerance, but the consistency is called eventual consistency. Once you say eventual consistency, here the reads and writes are quite fast. Now, there is another type of key value stores where you see that consistency is given more importance than partition tolerance, where availability may not be true. So, such as the banking applications etcetera will require, and HBase is one such key value store which ensures the consistency. Now, with the recent development that all of them they offer not the acid properties, but they follow base property, basically available soft state cons. Now, new kind of development which says that key value store which can support the acid properties, and they are called new SQL. They are being under development, such as Google's Spanner system. So, we have so far seen the use of cap theorem in designing the key value store or the storage server technology at the edge and the cloud, which is used for the latency sensitive application support for different type of IoT applications. Thank you.